Hi friends, we have discussed introduction of systems of particles and rotational motion. Then what type of motions can rigid body have? We have seen it and these are three types. One is a translational, one is a rolling translational plus rotational and third is a precession. We are only going to discuss rotational motion in this chapter. To discuss rotational motion, we have to consider the center of mass. What is the meaning of center of mass? It is 7.2 center of mass. Now see that center of mass, if you ask the definition, the center of mass is a point where the whole mass of a body is supposed to be concentrated in order to study its motion in accordance with Newton's laws of motion. This is the definition of center of mass. But let us see what is the meaning of center of mass. There are one object, suppose this is one object, point object, then we consider or we apply force at this point and this is considered as the point of action. There is no confusion for single particles. One point, there only the force is applied. But now there are two particles. This is one and this is another one. It is M1, it is M2. And if the force is applied, what will be the point where the force is effective? From geometry of the figure, it is very simple thing. Whatever force is applied, we cannot apply force here or we cannot apply force here. We have to apply force in between these two. So from this one, center of mass is always in between these 2 points. It is always along the line joining these two particles. Then where it will be? It can be. First thing is that it is along the line joining these two particles. Now, what will be the location? Location also differs according to mass of these two particles. If both of them are of equal masses, very simple logic indicates that center of mass is at center. If both of them are, but suppose that this mass is heavy, then it will shift to this side. This mass is heavy, then it will shift to this side. So center of mass shifts towards the heavy particle and then we get one equation. That is, suppose we take it as origin. Here it is 0, 0. Then center of mass x is given by m1 x1 plus m2 x2 divided by m1 plus m2. X coordinate of center of mass is given by m1 x1. It is x1 is nothing but it's a x coordinate of this one. m2 x2. x2 is nothing but it's a x coordinate of m2. m1 x1 plus m2 x2 divided by m1 plus m2. It is the x coordinate of center of mass. Similarly, y coordinate of center of mass is m1 y1, m2 y2 divided by m1 plus m2. This is y coordinate of center of mass. Now, this y coordinate again, y1 is y coordinate of m1, y2 is y coordinate of m2. Now let's extend it to the three particles. When it is the three particles, then that is this two is a center of mass and then this is considered as combination of these two and this is third one. So again for that one it becomes m1 x1, m2 x2, m3 x3 divided by m1 plus m2. Y is equal to m1 y1, m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. So we keep on adding one point, one mass, and then here now 3 converted into single particle. Then 4 also we can convert into single particle system. Then n number of particles are, suppose that m1, m2, m3, so on, mn are masses of n particles which are having coordinates x1, y1 and so on, xn, yn. Then x coordinate is m1, x1 plus m2, x2, so on, mn, xn divided by m1 plus m2 plus m3 plus mn. Y is equal to m1, y1, m2, y2, so on, mn, yn. m1 plus m2 plus mn. This can be replaced by x is equal to summation mi xi, I goes from 1 to n, summation mi. This is equal to 1 by m, summation mi xi 1 to n. Similar way, y coordinate is equal to summation mi yi, I goes from summation mi, which is equal to 1 by m, mi yi, I goes from. Summation signs you all understand. This sigma is a Greek alphabet. It's replaced by summation. Now this one, from these cases, you can easily understand this all. Here you can see, let us consider this one. Suppose m1 is equal to m2, then x is equal to x1 plus x2 divided by 2. When both of them are, this one is m1 is equal to m2, then it is becoming x1 plus x2 divided by 2, and which is nothing but, it is, if they are again at equal distance, suppose x1 is equal to x2, then x is equal to x by 2. This is in case of symmetrical objects. The always center of mass is at the center of their geometrical center. Center of mass is at their geometrical centers. So once again I repeat it. That is, for any symmetrical object, the center of mass is at their geometric centers. Now suppose R is there. Whenever R is the center of mass, then we write it as Ix. This is Yj plus Zk, where x is equal to summation mi xi divided by m. Y is equal to summation mi yi divided by, and z is equal to summation mi zi divided by m. So this is the case of R, x, y, z for symmetric object. Consider, this is the scale, this is the center. Now for symmetric object, it will be at the geometric center of that object. So whenever we consider center of mass of the symmetric object, it is nothing but it's a geometrical center. This is very important, and it can be proved by reflection concept. For example, there is this mass. We can divide it into small strips. These all masses we are dividing into small strips. This is at x. This is at minus x. So its mass is m1 and its mass is also m1. So this is a compensating this. When I take it, m1x, this comes minus m1x, which becomes 0. Reflection. This can be understood by concept of reflection. Similarly, we can take this one, m2, this is also m2. So there, sum becomes 0. Like that, when we go on adding this symmetric one, finally we reach to 0. There, sum becomes 0, and this is explained by using concept of reflection. Let us see now, when these particles, when they are very close, then it becomes this summation one. X is equal to summation mi xi, I goes from 1 to n, summation m. Now, this first one, m1 is delta m1. We have divided object into small elements. When we go on dividing them small elements, then this x becomes summation delta 1 x1 plus delta m2 x2 and so on delta m3 x3 or xn divided by summation delta m1 delta m2 summation delta m3. It's a sum there. Now this one, when we are taking it, it becomes summation I goes to 1 to n delta mi xi divided by capital M. Now here, when these are very close, it's a continuous distribution, then we replace this by integration dm. So it becomes, which is equal to x integration dm divided by m. This summation sign is replaced by integration sign. So x is equal to 1 by m integration x dm. Y is equal to integration y dm. Z is equal to integration z dm. Let's see how to use this one. In later part of this chapter, we will see how to use it. But time being, you keep it in mind, when the distribution of the body is a continuous, then the center of mass or coordinate, x coordinate is given by 1 by m integration x dm. Y coordinate 1 by m y dm. Z coordinate 1 by m z dm. These are the different coordinates we can find out by using integration. That's all for this. Thank you.